Okay guys, I'm just going to talk about analytical contrast and experiment-wise error in this slideshow, and in the next slideshow I talk about how to actually do planned and unplanned contrasts. So this is stuff we covered in week 5. In week 4 we learnt how to do a one-way ANOVA, which is basically when you have an IV with 2 or more groups. If you had only 2 groups, you generally use the independent samples t-test. So normally you use an ANOVA if you have 3 or more groups in the IV. A one-way ANOVA is 3 or more groups in the IV and a metric DV. So when you run your one-way ANOVA in SPSS, we get an overall omnibus F, which gives you the result, which tells you that at least one pair of groups differs significantly. It doesn't tell you that all of the pairs of the groups, of the 3 groups, differ significantly. It just tells you that one pair differs significantly, and you don't know which one actually differs significantly. Okay? So this is why we do analytical contrasts. Analytical contrasts allow you to run some follow-up analyses when you have a significant omnibus F to determine which pairs of groups actually differ significantly. However, when you run these follow-up analyses, you will increase your chance of making a type 1 error. A type 1 error is when you reject the null hypothesis when you shouldn't have. So you say you have a significant finding when there actually is no significant finding in the population. Okay, so if we decide to test at the 5% level of significance, then every time we reject the null hypothesis, we are prepared to accept a 5% chance of making a wrong decision. Suppose that there is no relationship in the population. If we make one analytical comparison, there is a 0.05 or 5% probability that the F ratio will be greater than the critical value just by chance. That's what the p-value tells us, okay? So if there is a 5% probability that we'll make a type 1 error. If we test 2 hypotheses, then there is a 5% chance of making a type 1 error on each occasion, each time we look at these hypotheses. Thus we have a 10% probability of making at least one type 1 error in the analysis. This is known as the experiment-wise error rate. Okay? If we make 3 analytical comparisons, or we test 3 hypotheses, then we have a 15% chance of making a type 1 error, because each time we test a hypothesis we have 5% chance, and we're doing this 3 times. So across the experiment we have 15% chance of making a type 1 error. So in deciding how to control experiment-wise error, researchers usually take into account whether they're dealing with planned or unplanned comparisons. Comparisons which are formulated during the planning stages of the research before the experiment is conducted are known as planned comparisons. So basically, if a researcher the previous research has been done, or there's some theoretical basis for predicting that certain groups will differ, then you have specific hypotheses which will determine which groups you will compare in your analytical contrast. So instead of comparing all of the groups to each other, you will only compare some of the groups to each other, and this will reduce your experiment-wise error rate and conserve the adjustment of the p-value. So you specify your contrast coefficients and by doing so determine how many contrasts you're going to conduct. You test each contrast at alpha divided by k. Alpha is 0.05, so alpha divided by k, where k is the number of contrasts. If you make only a small number of planned comparisons, the theoretical increase in experiment-wise error can be counted for approximately by testing each comparison at alpha equals 0.05 divided by k, where k is the number of comparisons. So we said before that if you run 2 tests, if you test 2 hypotheses or run 2 analytical contrasts, then you end up with 0.05 times 2 chance of making a type 1 error. You end up with a 10% chance of making a type 1 error. So the way to keep the experiment-wise error rate at 0.05 would be to divide 0.05 by 2. So instead of testing at 0.05 for each of those hypotheses, you can test alpha at 0.025. And then when you multiply 0.025 by the 2 comparisons that you were doing, you keep the experiment-wise error rate at 0.05. Okay? So for example, if you're making 2 planned comparisons and you wish to use the 5% level of significance, the decision rule for each comparison would be the difference is significant if the p-value is less than 0.025. If 3 planned comparisons were made, the decision rule for each would be alpha divided by 3, so 0.05 divided by 3. So the difference is significant if the p-value is less than 0.017, because 0.05 divided by 3 is 0.017. Whereas if you kept the p-value at 0.05 for each of those comparisons, then you would end up with a type 1 error rate of 15%. So an experiment-wise p-value of 0.15 instead of 0.05. Okay? So you would specify the contrast coefficients, test each contrast at alpha divided by k, where k is the number of contrasts being conducted. Alternatively, a researcher can use unplanned or post hoc comparisons, and this is when we have no specific hypotheses about which of the groups. So if you've got an IV with 3 groups, you've got no specific hypotheses about which of the pairs of groups will differ. So instead you compare all the groups to each other. So for unplanned comparisons, instead of using the adjustment I described for the planned comparisons, which is called the Bonferroni adjustment, we use one of the post hoc tests provided by SPSS. These tests keep the experiment-wise error rate of 0.05. So they will allow each pair of the 3 groups to be compared. So there'll be 3 to the power of 2, so there'll be 6 comparisons. So group 1 will be compared to group 2, group 1 will be compared to group 3, and group 2 will be compared to group 3. So there'll be 3 comparisons. And SPSS, when using a post hoc test, and when deciding whether any of those pairs differ significantly, will keep the alpha level or their type 1 error rate over the set of comparisons at 0.05. We don't need to know how it does that. Just it's sufficient to know that the type 1 error rate will be kept at 0.05 when you use one of the post hoc tests provided by SPSS. So a really common one is the student Newman-Kuhls, which we'll use in this course. The probability of making at least one type 1 error in the set of unplanned comparisons is less than 0.05, and applying these post hoc tests is equivalent to testing each individual unplanned comparison at a much lower significance level, much like the planned contrasts, where we divided alpha by k. In SPSS, we use the student Newman-Kuhls test. Okay, so if you guys can watch the next video, I'll actually show you how the contrasts are conducted in SPSS.